Namaste guys. Welcome to the part 2 of the first session of the ESP32 Playground series. The Playground series will have less theory and more of coding. So without delaying, let us get started with part 2 of the motion detector using ESP32. As mentioned in the part 1 of the video, this session will be divided into three main parts: creating the PIR sensor component, adding the configurable variables to the PIR sensor component, and finally switching the bulb on and off based on the configured threshold. Now we have covered the part 1 in the previous video. If you haven't watched it yet, you can find the link to the video in the description, and also you can click on the YouTube card shown above. So before moving on, please subscribe to our channel so that you don't miss out any of our upcoming updates. So in this video, we will be combining the part 2 and the part 3. So now let us begin with the part 2. Now let's begin with part 2 of the session, which is adding configurable variables to the PIR sensor component. Now, in order to add configurable variables to the PIR sensor component, we make use of kconfig file. Kconfig is used to provide compile time configuration mechanism. So we use menu config to edit these configurations. Now I will be creating a separate video in near future explaining in detail about the kconfig. But for now, let me just open the kconfig. So let me go to the PIR component directory, and in that we have this kconfig. So let me open that. Now let me add the first variable, which is PIR sensitivity. So we'll start with config followed by the name of the variable. It's generally a good practice to add a suffix to the variable which will uniquely identify the component to which this variable belongs to. Now since this is a PIR component, I'll start with PIR followed by sensitivity, sensitivity and EMS. EMS signifies that it's in milliseconds. And then we have to define the data type, which is integer, and then the title. So PIR component sensitivity in milliseconds. Then we can give a default value. So I will give the default value as 500 milliseconds. And then I will give range. So I'll give the range as 500 milliseconds to 2000 milliseconds. So now what happens is when we go to the menu config and if we try to edit, right, so we cannot give values which does not meet this criteria. So I cannot give any value which is less than 500. I cannot give value which is greater than 2000. And then we add help. So this is like how frequently should we read the data from the PIR sensor in milliseconds. Okay. Now let us create the second variable, which is keep alive duration after motion detection. So again, we go here. We'll start with config, the name of the config variable. So we'll start with PIR, motion, keep alive. Yes. So in this case, I'm adding yes because we'll be capturing the data in seconds and not in milliseconds. So the data type will be int and the title would be keep alive duration in seconds. So I'll give the default value as 5 seconds and let me give the range from 5 seconds to 300 seconds, which is nothing but 5 minutes. In the help, let me add keep alive duration once the motion is detected. Let me build the project and see if there are any errors. Now, once the project builds successfully without an error, we need to run the menu config. So before that, let me just expand this terminal and we need to click on run menu config over here. Now in this, first we need to select the component config. So in this, we will have all the components, like it will have the ESP-IDF components and it will also have the custom components created by us. So first we'll select the PIR component. So as we can see here, the default values are being selected. So the default value for sensitivity is 500 and for keep alive duration is 5 seconds. So if I click on it, we'll be prompted with this dialog to edit. So what I will do is I will set this to 400. So it will throw out an error as it does not meet the criteria, the range. It's below the range. So again, let me give something greater, 2001. Again, same issue. So now what I will do is I'll set this to 1000. It works. Same, I will update it for the keep alive duration. I will make this 10 seconds. And also few of my subscribers have told me that they cannot move up or down using the bottom and top arrow buttons. So in such cases, you may try the following buttons: J to move down, K to move up, escape to go back. So let me go back now. Yeah. So save configuration. And by the way, do not forget to save this. So I'll click on Y to save this. Now let me go back to the PR component source file. So let me close this and I will go to the .cpp file. So in this, you guys can see we are reading the data in an infinite loop. So this is the infinite for loop. We are reading the data in this loop. So we are using GPIO get level. So we are reading the data in this infinite loop. But we are not reading the data continuously, but we are giving some delay. So during this delay, the RTOS task will remain blocked. Now let me explain this in detail. So as mentioned in the part 1 of the video, we use macro PDMS to ticks to convert that data from millis to ticks. Because if you guys can see here, this expects the data of tick type. Okay. So yeah, so this macro converts this 500 millis to some tick value. Okay. So now let's assume the PDMS to ticks returns 100 when we give say X. So let's assume this is X, and for this X value, the PDMS to ticks returns 100. Now what happens is this task will remain blocked for the next 100 ticks of the microcontroller, and only after this the next statement in the loop will get executed. So to summarize this, right, the task is said to be blocked when it's waiting for resources and not consuming the CPU. This tick type varies from microcontroller to microcontroller. Just for your information, Arduino delay is not same as that of FreeRTOS delay. Arduino works in a super loop architecture. So there is only one super loop or one task, unlike RTOS where there are many tasks. So in Arduino, adding a delay will cause starvation to the other operations, whereas in RTOS, only that particular task will be blocked or delayed. Now we can control how frequently we want to read the data from the GPIO pin by simply controlling the delay value. So let me replace this hard-coded 500 with the kconfig variable, Pir sensitivity. So now we can easily access the variables defined in the kconfig by just typing config underscore. So here we can see all the variables that are present in the kconfig. But since we need just the PIR variables, so let me add PIR. So as we can see, there are two PIR variables. So let me select the sensitivity. So all the configurable variables starts with the suffix config followed by the name given to it in the kconfig file. So in case the PlatformIO do not recognize the config variable in the source files, no need to panic. Just clean and build the project again. Now let's add the second variable, which is keep alive duration. So the logic here is that when the motion is detected, we want the light to be remained on for some time. So if the motion detected state is true, then below this log, let's add the delay, vtask delay, and then we'll use pdms to ticks. And now let's access the config variable, which is keep alive. So, but here this keep alive value is in seconds, but pdms to ticks expects the data in millis. So we'll multiply this with 1000. So now let's build this project and see if there are any errors. So now there are no errors. So let us go ahead and connect the relay. So this is the last part of the video, which is switching the bulb on and off. So as shown, this is the final circuit diagram and we shall be connecting the relay trigger to the node MCU pin 14. So we'll be using a solid state relay here and an AC source and a AC bulb. Now once the circuit connection is done, let's get to the coding part. So first let's begin with initializing our output GPIO pin. But before that, right, let me do some changes over here. So I'll declare a variable ESP-IDF and I'll call this as return code. And the default value would be ESP OK. Now instead of returning directly here, I'll just make this equal to. And then let us declare a if condition. If return code is not equal to ESP OK, then let me log a error. So we'll use log E. Tag the PIR GPIO pin was not initialized, and I will return the return code. So now what I will do is I'll just copy this and paste it below. I will rename this from, sorry, I'll rename this to Pir config to relay config. I'll pass the same over here. And instead of the Pir GPIO pin was not initialized, I'll rename this to relay. And instead of returning here, I'll just return it outside the if condition. Then this pin will be pin 14 and this will be output. Let me align this. So now let's cross check the code. First we are initializing the GPIO pins, then return code. First then is Pir config pin number 2 input. We are passing it over here. So if it is not equal to ESP OK, then the Pir GPIO pin was not initialized and we're returning. So only if the return code is ESP OK, we go here, which is relay config, which is for pin number 14, which is in output mode. We pass it here. And if the return code is not equal to ESP OK, then the relay GPIO pin was not initialized. Yeah, seems good. Now once the relay pins are initialized, let's switch the bulb on and off. So in order to switch the bulb on, right, just below this log, we need to do GPIO set level, and we need to pass the GPIO pin, which is pin number 14. So GPIO number 14 and pass high. And here when no motion is detected, that will be low. So here, if you see that there is a delay, right? So when the motion is detected, the light will be switched on here and it will remain on till this delay. Like for example, if it's say 5 seconds, the light will remain on for 5 seconds. If it is 5 minutes, the light will remain on for 5 minutes. So guys, let's upload and monitor the logs. So guys, this is the end of the motion detector using ESP32. If you guys think this video was helpful, please do like the video and do support us by subscribing to our channel. If you guys have any concerns or you want me to create a video on some topic, so please do add your thoughts in the comment section. Jai Shri Ram.